Hello student, I am Om Prakash Dubey. I am teaching chemistry. I am faculty of chemistry. Today I am discussing in Ionic Equilibrium chapter. As we know, weak electrolytes do not ionize 100%, do not dissociate 100% in the aqueous solution. That is, they dissociate partially, and in the solution, the undissociated weak electrolytes and the ions produced by the weak electrolytes both are present, and the equilibrium is established in between the undissociated weak electrolytes and the ions produced by the weak electrolytes, and this equilibrium is called the Ionic equilibrium. Then Ionic equilibrium is simply the equilibrium established between the undissociated weak electrolyte and the ions produced by the weak electrolytes in aqueous solution. It is called the Ionic equilibrium. Let us an example of the weak acid, that is acid equilibrium. Suppose a hypothetical acid HA which is dissolved in water, Now the HA, the hypothetical acid, is aqueous. The H2O is a pure liquid because it is in excess quantity. Like it dissociated as H3O positive and A minus aqueous and the H3O positive aqueous. And the weak acid do not dissociate 100%. The undissociated weak acid and the ions produced by the weak acid, the equilibrium is called the Ionic equilibrium. Then we are discussing here the dissociation and dissociation. Now the dissociation and dissociation constant of weak acid. Dissociation and dissociation constant of weak acid. Like weak acid which do not ionize 100%, do not dissociate 100%. Suppose an example of organic acid which do not ionize 100%, like acetic acid, which do not dissociate 100%. When it dissolved in water, it ionizes, it partially ionizes, it gives acetate ion and the H3O positive. Acetic acid is aqueous, water is a pure liquid, acetate ion, aqueous, H3O positive, it is aqueous. Suppose the concentration of the acetic acid in the aqueous solution is C moles per liter. The concentration, let us assume the concentration of acetic acid is C moles per liter. Since water is in excess quantity, it is a pure liquid, the activity, the molar concentration of water in this case is taken to be 1 because it is a pure liquid, its activity or molar concentration is 1. Initially the concentration of acetate ion and the concentration of H3O positive is 0. This is before dissociation. Before dissociation, the concentration of acetate ion and the H3O positive ion concentration is 0. Let us suppose the degree of ionization, the degree of dissociation of this weak acid is alpha. The degree of dissociation is alpha. Degree of dissociation. And what is the degree of dissociation? Degree of dissociation or degree of ionization. Degree of dissociation or degree of ionization. It is actually denoted by the alpha. And degree of dissociation or degree of ionization is defined the number of moles of weak electrolytes dissociated when 1 mole of weak electrolytes dissolved in water. That is number of moles dissociated per mole. Number of moles of weak electrolytes dissociated per mole of weak electrolyte. Then we can also say alpha, the degree of dissociation, which is equal to the moles dissociated upon moles taken, or initial moles dissociated and the moles taken. Now if the concentration of acetic acid is C moles per liter, and if the degree of dissociation of this acetic acid is alpha, a dissociated C alpha, and if dissociated C alpha, the acetate ion formed in the solution is C alpha, and the H3O positive ion concentration in this solution is C alpha. That is, at the equilibrium, the concentration of this weak acid is C minus C alpha, that is C1 minus alpha, and the concentration of acetate ion is C alpha, the concentration of H3O positive is C alpha. Now, we can calculate the dissociation constant of the weak acid, this weak acid, and the dissociation constant of this weak acid is K. K is the dissociation constant or the ionization constant of the weak acid, and the expression of this dissociation or ionization constant is the concentration of acetate ion, concentration of H3O positive, that is H plus ion concentration, upon the concentration of weak acid, acetic acid. Since it is a pure, water is a pure liquid, its activity or concentration is taken to be 1. Now, the K is equal to the dissociation constant of acid is equal to the concentration of acetate ion at equilibrium is C alpha, the concentration of H plus ion is C alpha, the concentration of acetic acid at the equilibrium is C1 minus alpha, C1 minus alpha. Now, this C and this C, C alpha square upon 1 minus alpha. Now, the dissociation constant of this weak acid can be written as C alpha square upon 1 minus alpha, that is Ka is equal to C alpha square upon 1 minus alpha. This is the dissociation constant of this weak acid, and from here we can calculate the degree of dissociation, the extent of dissociation of the weak acid if the dissociation constant of the acid is given, or we can calculate also concentration if the degree of dissociation and the dissociation constant is given. So from where we can calculate the degree of dissociation, the dissociation constant, the concentration of H plus ion in this aqueous solution, the concentration of acetate ion in this solution. Now we can calculate all these H plus ion concentration, acetate ion concentration, dissociation constant, and the degree of dissociation of this weak electrolytes. Thank you.